Hello, welcome to tutorial 4 and 5. In this video, I will review about chapter 5 and 6. Okay, for this chapter, I will just review a bit what we have learned in the class. So for the network optimization models, the phase 2, Palisky already have demonstrated how to calculate it with sulfur in the class before, so I will just review. So the description is the vice president of supply chain Sun Oil is considering several options to meet demand by set up a facility in each region or consolidate plants in just few regions. Sun Oil is considering two plant size in each location, which are low capacity plants that can produce 10 million units a year, and the high capacity plants that can produce 20 million units a year. The vice president wants to know what is the lowest cost network that can still meet their global demand. So from here and also from the book, we already have this table. It is given by the information that we have. This table is the inputs that contain cost, capacities, and the demands. From this table, we can know that Sun Oil have 5 supply regions and 5 demand regions, and the fixed cost for each plant size also already have been known in here. So for the annual demand for each demand region is, as you can see, in row 16 here. So for the North America, the annual demand is 12 units, and South America is 8 units, Europe is 14 units, and so on. Actually, the number here is all the numbers here is in million, but we just simplify it to make it easier. And this group of cells is represent the variable cost of producing in one region to meet the demand in the demand region. So for example, if the variable cost here is $92 to produce 1 million units in North America and sell it to the South America. Another example is here. So the variable cost to produce in Europe and sell it to Europe is $95, and so for producing in Africa, the variable cost is $100 to sell it to the South America, and so on. And for the fixed cost, for the low capacity size, the North America have the fixed cost of $6,000, the South America have $4,500, and so on. And for the high capacity size, the North America have the fixed cost of $9,000, the Europe have $9,750, and so on. And then we move on to the next table here, the decision variables. So the cell is empty, as you can see here, and it will be fulfilled later by the software. So this group of cells represent the number of units that is produced in supply region and sell to the demand region here, and the cells in here is represent the binary number where one means that open and 0 is not open. This is for the plants with the low capacity size, and this is the plants with the high capacity size. And we will found it later by the sulfur. For the constraint, we need to use the formula in the cells that I have colored with orange and green here. So for the excess capacity, the formula is the capacity times the decision whether we will open or not, and the low capacity of North America plus the high capacity times whether we open it or not minus the sum of the amount of products that is sold from the North America plant. There, then just enter, and for the rest of it just drag to copy. So for the South America, it is also the same, the low capacity times the value here, whether the low capacity in South America is open or not, plus the high capacity times the value here, whether we open the high capacity plant in South America or not, minus the sum of cells here about how many amounts that is sold or produced from the South America plant, and so on. And for the unmet demand here, just put the demand from the first table where the annual demand for the North America is 12 minus sales here, how many amounts of products that is fulfilled in North America. And wait, don't forget to put the formula. Okay, of course it is will be 12 because the sum is not yet filled with the numbers, and just drag it to copy the formula. Okay, next for the objective function, the cost, the formula is sum product and just pick the group of cells in here and comma the group of cells in here. So the means of sum product is this group of cells, the variable cost, the blue one here, times the red cells here, the amount of products that is actually sold, and then plus the sum product again. Wait, um, the fixed cost in low capacity, comma, yeah. So for this, the means is the fixed cost of low capacity times the value whether we open the low capacity plants or not. So if we don't open the low capacity plant, then the fixed cost will be zero, and if we open the low capacity plans, then the fixed cost will be like here because it just times by 1 or 0. And next is high for the high capacity plan. Also the same, just fixed cost here, comma, the value here. And then just enter. So and if we already input all the numbers and the formulas, we can move to the next step, that is solver. So data and then solver. Set objective is the cells here where we already put the formula, the cost. And for this section, pick min because we want to minimize the cost, and by changing variable cells, pick all the yellow one here. This is what we want to fulfill. And for the constraint here, it represents the number of units that is being produced or sold, so it needs to be greater than or equal to 0 because we don't want it to be a negative number. Click add, and then for the excess capacity here, also the same, greater than or equal to 0. And for the unmet demand here, just put equal to 0 because we want to fulfill all the demands here. And then for the plans, for the column here, the plans low capacity and plans high capacity, put the binary number because we want to know whether it is 1, which means open, or 0, which means not open. Okay, if done, click OK. And don't forget to put a solving method here, simplex, and click solve. Okay, we already got our results here, and the demand is fully satisfied. So from the solver, we can conclude that for the lowest cost network, the Sun Oil need to open the high capacity plant in the South America, and then in Asia and in the Africa, with their total cost is here $23,751. So from this table, we can see that the demand in South America, which is egg, is fulfilled by the supply region in South America, and the demand in Asia, which is 16, is supplied by the Asia itself also. And for the Europe, their demand is fulfilled by the Asia and Africa. And for the North America, the demand is 12, and their demand is fulfilled by the supply in South America, and so on. I think that's it for the network optimization models. And next. Okay, next is the capacitated plan location model that you guys have been working on with your group before, so I will just review a bit. So the management executives at both Telecom One and High Optic have decided to merge the two companies into a single entity called Telecom Optic. The management is debating whether all the five factories are needed. It has assigned the supply chain team to study the network for the combined company and identify the plants that could be shut down. So they could minimize their costs and still meet their demands. So we have the first table here. This is the inputs of cost, capacities, demands for telecom optic, and this table is given based on the information that we have. So the telecom optic has five factories here, which are Baltimore, Seattle, Salt Lake, Memphis, and Wichita, and they have six market or six demand city, which their demand needs to be fulfilled, which are Atlanta, Boston, Chicago, Denver, Omaha, and Portland. So this group of cells are the variable cost from each plant to each demand city. So for example, the variable cost from Baltimore to Atlanta is $1,675. And another example is from the Salt Lake to Denver, the variable cost is $500 and so on. And then this last row is the demand of the six market that we need to be fulfilled. So from Atlanta, the demand is 10. From Boston, the demand is 8. From the Chicago, the demand is 14 units, and so on. And the next is the column of fixed costs. So, for example, for the Baltimore plants, the fixed cost is $7,650. For the Salt Lake, the fixed cost is $5,000, and so on. And this is also the capacity for each plant. So Baltimore has 18 units. For the capacity, Salt Lake has 27, Wichita has 31, and so on. And then the next table is the decision variables. First it is empty like this, and it will be fulfilled later by the solver. And from this table, we decide how many units that will be shipped from Baltimore to each demand city, from the Salt Lake to each demand city, and so on. And we also decide which from these five plants that will be open or will be shut down. And this is will be known later from the solver. And for the constraint, uh, it is we got this from the formula from the book. So I already assigned the color codes here where the yellow one like this is will be known later from the software, and the pink one here will be from formula and the software, and the green one is only by the formula. Okay, next. So for the excess capacity from Baltimore, the formula is will be the its capacity times here plants, where 1 is open and 0 is shut down. So the capacity will be times by the value here minus the sum of how many units that will be shipped from Baltimore. And for the CN plants also like that, the capacity for the CN times the value here minus the sum of how many units that will be shipped from CN, and so on. You can just calculate. And then for the unmet demand here, the formula is just the demand from the first table minus the sum of how many units that are shipped to Atlanta. And then for the other dimensity also like that, the formula is from the books. And then the objective function is of course to minimize the cost. The formula here is the sum product of these cells, the blue cells, times the red cells here, plus the sum product of the fixed cost and the value here, whether the plant is open or shut down. So the sum product is like these blue cells times the red cells plus the purple cells times the green cells. So to give you some picture, okay, so for example, to differentiate of sum and sum product. So for sum is just a simple like this. I'm sorry. So for sum it is just a simple like 1 plus 2 plus 3 and plus 4 plus 5 plus 6, and we got the 21. And for the sum product it is like this. So sum product is like 1 times 4 plus 2 times 5 plus 3 times 6, so we got 32. So sum is just plus, and sum product is there is a plus and times. Okay, if we have input all the data and the formulas, we can just move on to the solver. It is on the data tape, and here you can click the solver. Okay, for the solver, for the set objective, just pick the cells where we have put the formulas in the objective function. So I will just click here where I already put the formulas, and then it will automatically show the cells number. And in this section, pick the mean because you want to minimize the cost here. And by changing variable cells, pick all the yellow cells because this is what we want to see. And then for the constraint, pick the group of cells here because it represents the number of units that will be shipped from the supply city to the demand city, and it needs to be greater than or equal to 0, because of course we don't want it to be a negative number. And then for the capacity here also the same, it needs to be greater than or equal to 0. And then for the cells here, the unmet demand, it needs to be equal to 0 because we want to meet all the demand here. And then lastly, for the column plants here, it needs to be binary, where it will show the value of 0 or 1, where 1 represents that the plant is open and 0 represents that the plants need to be shut down. Click OK, and don't forget to select a solving method to simplex, and then click solve. And we already get the results here. Please don't mind too much about this number with alphabet E. It just means the decimal numbers, and the one we need to be focused on is in this row the plans and the cost. So based on the solver method that we have compute, we can conclude that the telecom optic need to shut down two of their plants, which are Salt Lake and Wichita, because it show the value of 0, and they need to open the three others of their plants, which are Baltimore, Seattle, and Memphis. And with this kind of network, they will get the total cost of $47,401. I think that's it for the capacitated plan location model in chapter 5. If you still feel unclear or you need to ask the question, please don't mind to chat me through personal chat or group chat. Thank you.